Hello guys, welcome back. We are going to continue from the previous work. Now we have the all the members drawn here, right? So this is the structure that we drawn last time. If you want the information about this one, like how to draw these members, like I will put the link into the description box below, so you can go through that one and do like make the structure first and come here to see this video, so you can do more work on this. Today we are going to apply the boundary condition, loads, and do the analysis on this one. So first of all, I'm just going to go and show you the firstly like the same thing project statement that we have here. The thing I want to show you here is the load. We have dead load of 10 pound per square foot, roof live load of 20, and wind load generated by the 115 mile per hour, and the ground snow load of 50 pound per square foot. So these are the load we are going to apply, and we are going to apply the load combination based on the ISC specification, and then we will do the solving of these problems. So let's go to the RISA 3D, and this is the structure that we have here. So first of all, I'll show you how to apply the boundary condition, then we will apply the loads. For the boundary condition, we are going to make it easy. It depends upon you, but normally to make it easy, we are going to apply the fixed boundary condition for the each column that is connected to the ground. Okay, here we are going to apply the boundary condition of this for this structure. So as I said, like I'm going to apply the fix. Just click on this icon here into the model view window. It will give you the boundary condition icons here. So in this way, you can apply any kind of boundary condition that you needed for the any joints or any member here. So but I want to apply the once because I have to apply the fix for the all the columns here. So you can go to the XY axis here, and we have the whole structure just behind just perpendicular to the screen. So click on this one. I'm going to make fixed all. So just click on a fix and click apply and select the base part. So it already applied the fixed boundary condition to the all the structures. You can see in the isometric view here. So after applying the boundary condition, the next thing that we are going to do is applying the load. So for the dead load and live load, we have given for 10 pound per square foot and 20 pound per square foot. That's pretty easy actually to do that. So okay, let's do that one. For before applying the load to the structure, we are going to assign the basic load cases. There is BLC icon here. Click on that one, and you just need to provide the different load: dead load, live load. Yeah, we have snow load, and we have wind load in X direction. Yeah, we have a wind load in all directions, which is X, Y, Z direction. So I will show you every how to do in all the directions, but here I'm just going to do in the X direction because it was very long if I do in all directions. So I just want to make it a little bit short and quick, but the method is same way. And go to the category and select the category for all load. This is dead load, this is the roof live load, and go on this one and click on snow load. This is wind load in X direction. Go down and select the wind load in X, what is that, wind load in X direction, and just cancel it. So now we are going to apply the dead load first. So for that one, our dead load is 10 pound per square foot. So let's go to the Visa 3D and apply the dead load. For that one, go to the insert and click on the area member load. And our dead load is, click on the basic load cases that you have defined. Dead load, 2OA load in Y direction. Our dead load is 10 pound per square foot in -10. Be careful about the unit here. It's PSF. I have already made it. Otherwise, like just go and click on this section and change the unit. I'll just show you quick. Go and click here and change the surface area load unit from here. It normally in default it will be KSF, then change it to PSF. So I have PSF here already. So I'm just going to go quickly on that area member load here. It is 10 pound per square foot in Y direction. Apply there, and it's trend, right? Yeah. Apply. No, this is a dead load, not the WX. Yeah, it's now good. So I'm going to apply here in this direction. So because our structure is not uniform, I'm going to divide them into different part and apply actually. So let's apply here because this is the area member, so it doesn't matter even if you apply into the different parts. So this is another part I'm going to apply. Okay, we have applied the dead load to all the area that we need. Here I'm going to show you how to copy the load from dead load to live load, because our live roof live load actually, our roof live load is 20 pound per square foot and snow load is of 50 pound per square foot and the area are same. So let's go here, and this is the icon just to hide and see your load. You can click on that, you can just hide your load. Go to the basic load cases here. Again, this is the load combination that we have assigned, and this 3 is because here we applied in the 3 area, we apply the dead load. So just to copy, there is icon here into the left corner, you can see, and just to do the copy of your icon load, click on this icon, copy icon. We want to copy from dead load to roof live load, right? Dead load to live load. Okay. Actually, this is roof live load. I have written here is LL. I think I can change that one from here. Just make it R. Roof live load. Okay. Now, if I want to copy, click on this one and want to change from dead load to roof live load. Why isn't it? Roof live load. Click on this one. Okay. It's already copied. Okay. It's copied and it's given here 3 already. So click on this box again, it will show you the load, but here we need to change into, it is not 10 pound per square foot, it is 20. So click on that one and change it to 20. I'll show you into the snow load also. It's already given there. Let me show you into the snow load. First let's see the snow load here and let's view that one. I think let's see the roof live load and we will know that one. Okay, now it is viewing, right? So it's showing the load, but snow load we haven't applied here. Okay, let's go and copy the load from BLC, copy the load from dead load to snow load. Okay, and then snow load is already copied, and let's change the, yeah, now you can see here in this background in snow load is coming to -10. If you change this one to -50, it will automatically change into the -50. Here you can see in all area, let's change it to -50 pound per square foot. Just cancel it. So we have applied all the roof dead load, you can see on that one, -pound per square foot here, and roof live load -20, and not the wind load, snow load -50 pound per square foot, like the 50 pound per square foot in vertical downward direction. So now we are going to apply the wind load. Let's just hide this one. To apply wind load, it's a little bit complicated and it's a little bit lengthy process than other. So I'm just going to show you how to calculate the area where we are going to apply the wind load first. I have ASC 710 here. Normally for the building, these are the area that you are going to apply the wind load. In X direction, A, V, C, D, and in Y direction, E, F, G, H. B are for the inclined roof. So in our case, we are this good luck for us, like we're gonna have inclined roof, so you don't need to do any calculations or any application of the wind load on that one. Like we are going to apply the A load up to the total height, and C load, E, F, G, H. So for this distance, this is 2A. We need to calculate this one. Here it's given in over in the 9th part of this note. You can see the A should be 10% of the least horizontal dimension, or 0.4h, whichever is smaller, but not less than the 4% of the least horizontal dimension, or 3 feet. So if you go to our project statement and see our that plan view, our least horizontal distance is, this is 150, right? This is 66. So 66 is the lowest one, and if you do this 10%, that is 6.6, right? So 6.6 or what is that? 6.6 or 0.4 h. 0.4 h is just 30 times 0.4 is just 1.2. So that, no, 12. So if you go on this least one, whichever is smaller, that is 10%, that is 6.6, right? But not less than 4% of the least or 3 feet. But not less than 4% or 3 feet. If you calculate the 4% of 66, let me calculate here. 66 times 4%, right? 4% is 2.64. That 6.6 is not, 6.6 is not less than 2.64, right? Okay, and the not less than 3 feet. Yeah, that is also okay. So 6.6 is our A value. Okay, this is given here, A value. So 2A value is 6.6 that we calculate times 13, not 13, times 2. That is become 13.2. So 2A value or this value will be, oh sorry, this value will be 13.2. For the height, we don't have any inclination, so total height is going to be there. So another thing I just wanted to show here is a little bit up on the ASC 710. These are the 8 different cases that you need to apply the wind load actually. Like keeping this one is 2A and A, B, C, D, and E, F, G, H again at the top is we saw in the last one, and another one keeping that one to the 8 different direction. The cases 8 different are, I can show you here. First is you are putting the A here, 2A here, right? And again 2A into the over here, and 2A into the same location but from another direction, opposite direction, and in same case into the another one. So 4 cases over here, and go to the another axis and 4 cases over there. In total there are 8 different cases of the wind load, but here I'm just going to show you the only one case, the first case actually, but the other are similar. You can just calculate the 2A in the similar way and apply the wind load. So to calculate the wind load for the each part, there is one table, yeah, just 2 pages below there is one table given here for the different wind pressure. Luckily our height of our building is exactly 30 feet, so you don't need to do any more calculation. But if it is more or less than your this 30 feet, you just need to do some interpolation to find out the exact loading. Our wind is 115 mile per hour, and the degree of that one is 0 to 5. We have a flat roof, so it's 0 to 5. So that's why this one is not the top one, this one, and why it's not clicking here. What if I click here? No, it's not clicking here. But this first line is the loaded A, B, C, D, E, F, G, H we are going to have. But one thing, as I told you earlier, there will not be any B and D because our roof is flat roof over there. So we are going to apply the load based on that. First, even though we know we are going to apply that one, we don't know how where is the 2A line, 2A point. So let's draw the 2A point first. As we know, 2A point is 13.2. I told you that one earlier, right? It is 10% of 66 is 6.6 times 2 is 13.2. Okay, let's go and make a point here in 6.2. First, let's draw a member. We are going to delete that one. I'm going to do in the similar way that I did last time. We are going to find out a 13.2 point here. But one thing I just wanted to tell you here is you need to be very careful from where did you start to draw, because like 13.2 from this point and 13.2 from this point will be different. So for that one, there is one way, like if you forget like where did I started and where I ended in drawing, you can just click on this icon here and then see the I and J. I is the first point that you draw, and J is the last point you draw. And the red icon, like in each member, red point is the first line you draw, and this blue one is the last point you draw. Normally, if you follow the same direction every time, it will be easier for you. So in our case, this is the first point. So go to the draw member icon again, split member. This time we are going to split the location not on the number of the equal pieces, based on the distance, right? We are going to 13.2 feet. You can apply any percentage or feet. Here also we are just going to add the point and apply clicking on the individual. Click OK and click here. it already made 2A point here, and just click on this one also. There is 1 point already made here actually. I think so. Yeah, there is 1 point already made here. That is the 2A distance we are going to have. So I'm going to delete this line. We don't need that one. So let's click here. Yeah, this is our 2A. So A load will be there. So A and C will be on the that case. And for EFGS, as I show you here in the PDF file here actually, what is that? I can show you. Yeah, EFGS are exactly from the half, but E and EFGS, like this distance is again the 2A. So go over here. We will make 2A distance. We are going to apply E in from here to here, but somewhere in the middle up to here, right? So let's divide this line first. I know I draw from this way to this way. I remember that one, so that's fine. That's good actually. If you don't know, you can just go and see the IJ again. So yeah, this is the red line and this is the blue one. So I draw from that side. So let's split that one again and into half. We know that that distance is total distance here to here is 66, right? Let's divide into 33. So go to here, split member specific location again and half, or you can just click on the number of equal pieces. But if you do number of equal pieces here, we drew this one separately and up to here separately is a beam and this is a girder. Remember it, keep it that in your mind. So it's better to go through 33. So click apply and click on this member. So we found the 33 here, and we are going to be needed at this end also. I just want to add point on here too. So we made this point, but one thing that we need to make sure is we need to find the 2A point for this one, like, because to apply EFGS. Let's go and find the parallel point here. For that one, you can just it's easy to do in this way, like this. Unselect all. This is the point that we need to copy. Just copy this one to that direction. 13.2. Remember that, right? One at negative 13.2. Click write that one over there and click apply. It copied that one. Okay. So and we will need over here also point. You can just copy in that way again, or you can just break like split this one or whatever you want. You can do that one anyway. Okay, I just copied that one from here and I made a new point here. Okay, now we are ready to apply the wing load. First, I'm going to apply A and C load. So for that one, like there are a lot of lines, so I just want to select the needed point only, and then that will be, I think that will be easier for me. These are the point to apply, not this one. These are the point to apply A load. I will show you like how much is the A load here. Our A load is 21. This one, not that one. I don't know why it's not clicking there. Okay, that's fine. But 21 is our all the load are in PSF, so that's the unit we are using. 21 pound per square foot is the A load. Let's go and apply the 21 pound per square foot. So here, go to the insert and area member load again, similar way, but here you need to be careful. We are applying to the X direction. First select which load you are applying, wing load X, go to the X axis and it's negative 21, right? Yes. Click apply and you can select now this area only. Yeah. Now we have A point. I just want to remove that one because I'm going to apply this C load here. So for C load, we will be needed this point and these points because our structure is not so uniform. Okay. Now I'm going to apply the C load. C load is how much C load you can see here again, and yeah, 13.9 is the C load in same direction. Similar way, just go here, area member load WX again, but here you can go and 13.9, right? 13.9. Click apply. I'm going to apply into the two step here actually because our structure is not uniform as I told you. earlier. Okay, one is done, and for second one you can click here and click here. So A and C are drawn. We have finished the drawing the A and C. I just want to get rid of those. And on select all again, I found it easier actually. That's why. So for E F G H, this will be F area. E area will be here. For G H area, you need to have these lines and these points. So this is the area we are going to apply the EFGS. Let's see the E. If you see E on our requirement, 25.2 is the E load that we are going to apply. This negative means upward, not the downward direction. Okay, so we need to apply in RISA 3 in the positive way. Okay, this is the E area. Let's go and apply the insert area member load in Y direction, vertical direction, but positive. How much was the value? 25.2. 25.2. So click on that one, apply from here. Okay, E is done. Our F is in the same way over here, but the load is, you can see on that PDF again, this is 14.3. Click apply and follow the direction. E and F is done. So for G and H, G will be this side and H will be that side. Let's apply the G. G is negative 17.5. Click apply, and the area will be this one, and here also G, and H is the remaining one. And for H, the value is 11.1. You can see on that PDF the table again. Like here, you can find that thing 11.1 in H. So for H value, I'm going to apply 11.1 in Y direction, the same direction. Okay, I think that already applied actually. Yeah, that's already applied. That was not showing here. So H is going to be complete. It's completed. Okay. Our load EFGH is also done. So if you see, if you like, there is A and C also, because we haven't selected these members, it is not going to show. Like we haven't selected those nodes, all the nodes required, so that's why it's not showing. If you click on select all member, this is your win load. So for that one, what you can see is, if you want to see the different load that you have applied, you can click on this one and you can see by clicking dead load, this is we applied, roof live load we applied, snow load we applied, and the wind load we applied here. So now we are almost done by applying the loads. I wanted to just tell you here is, like, this is the one case of load, right? Wind load, data and other load are okay. For another case, what you are going to do is, this is 2A here. Next time do 2A here, and A, C, E, F, G, H. Another time this direction, like into the positive x direction, 2A. So again A, C, and again E, F, G, H at the top, and here. So 1, 2, 3, 4 in x direction, and in G direction 1, 2, 3, 4 to A. So it has total 8 cases. So I just did only one. So it's a little bit longer. That's why. Now we have the we already have loads. So let's go and apply the load combination. So this LC is for the load combination. It has a LC generator, load combination generator also has RISA 3D, but I am going to show you in the manual way. You will find out when you click on the LC, you will find out this kind of table. Click on the window. So now this is the place to apply the load combination. Here we are going to apply it based on LRFD method. So for that one, I already have that still manual. you can have that AISC manual. So if you go to the page number 2-11, 2-10 actually, yeah, 2-10, you have LRFD load combination, and I think in 2-11 you have AST method. Yeah, this is the load combination we are going to apply here. So first load combination, just type load combination 1 and click on this one, period type S, because this is for the second order analysis. I'll tell you that one later. And here in the BLC, this is basic load combination. Click on this one and be careful, you should not click here. Just click on basic load cases. These are the basic load cases that we have provided here. Dead load, click OK. And first load combination is 1.4D, right? So 1.4 dead load. Done. Load combination 2. Load combination 2 is 1.2 dead load. And for another one, if you see here in load combination 2, 1.6 live load, we don't have live load, we have roof live load. Go to here, 0.5 times roof live load or snow or rain. This means like maximum of these. So in our case, the roof live load is 20 and snow load is 50. So snow load is governing here. So snow load times 0.5. So go to here, load combination, click on the snow load, click here, snow load times 0.5. Load combination 2. And for load combination 3, you can see this is same here, and let's see the 3. 1.2D plus 1.6 times same thing here. That means like we have snow load. 1.6 times snow load. Okay. Basic load is snow load. 1.6 times snow load. I think there is another one here. Something there. 1.6 times snow load plus whichever is maximum on this one. 0.5 live. We don't have live load, so we are going to apply 0.5 times wind load. So basic load combination as wind load times 0.5. In this way, you can make all the load combination for all the different loads. When you apply for all the 8 wind load, this will have your 8 load combinations. So there will be a lot of load combinations. So for example, I'm just going to show you these 3 load combinations here. So load combination is done. So I just want to get rid of these things. So now we are ready to analyze the structure. So for that one, you can click an equal button icon over here. When you click here, you will see this kind of window. If you click this one, this is single load combination. These are the 3 load combination I provide here. If you apply many, like there will be many, like list of the load combination that you applied. So, and second one here is envelope only. This means it will apply to, it will run for all the load combination that you provide here and give you the maximum load, like the result for the maximum one. So let's first run for this single load combination for, okay, let's go for load combination 1. We'll do that envelope 1 too. Let's solve this. Oh, there is no error. Yeah, there is no error. That's good news for us. This already solved our structure, so you can see whatever you want from now on this structure. Okay, this is the icon. You can see the shear force, axial force, bending moment, and all those things here. Just click on this one. If you want to see the bending moment in G direction, click on MGG, and it's gonna show you all the bending moment of your structure. Like if you want to see axial, click on the axial. It's gonna show you the axial one, and y shear you can see on the shear force in the y direction or everything. So another thing what you can see is, if you can see there is an icon over here. It is about the deflection of your member. You can click on this one and click with undeflected shadow. Yeah, if you see this one, this yellow are your deflection of your members. So based on that one, you can change the member. This is all the results are based on the member that we provided here, right? So one other good thing over here, what you can see is, if you want to see the result of each member and see is that one good or not good. So for that one, you can click on the detail icon over here, and there will be this kind of pointer, and go and point at any member you want. For example, if you want to see on this column or this in column, okay, let's click here. If you see there, you'll find a lot of results from that pooling. This is deflection given here. These are the all the properties that we provide here. This is for the code sec, that is the uh, KL by R value. Code sec should be always less than 1 over here. And this is the axial force you have. This is the shear force you have. This is the bending moment you have. No, this is the bending moment you have. Sorry. And this is the shear force you have. This is the axial force you have, and this is the deflection you have over here. And there is a lot of information given down over here too, like maximum bound bending moment was how much, where is the maximum bound bending moment. This is H1B equation from your AISC manual, chapter H 1-1B, the equation they applied here. How much is maximum shear check, location, maximum deflection ratio, compression flange, it is slender or not slender, all the value are given here. So, and okay, let's click on another one. It might be good for you. Let's click on the this girder. If you click on that girder, it's giving the similar kind of information. But one thing here is code check no calculations based on the 97 sections, and KL by R value is greater than 200. And if you go down, there is nothing. This is because the KL by R value, the slenderness value is greater than 200, which is not good for your compression member. For compression member, it should be less than 200. So that means this member is bad here. So we need to change that one. So because this result, total result is just based on the safe size that we provided here, right? We don't want exactly propagate the first one, because this is just hit and trial method. Like now we are going to go through the appropriate one. So one thing I wanted to tell you here is, if you you see a M here with the different colors, you can click on that one, and there are the different color for your member based on the uh, different properties. Like for example, if you click on the section set, it will give you all the members name based on the your section set that you defined in the spreadsheet. Okay, so another thing, like you can do many things like material set, like whichever type of material, A992 or A36, you can see those things. You can go on share check if there is some problem on the share check of each member. And when you click share check, there will be one color icon over here, and like based on this one, blue is good one. Like these are the ranges for your share check. Blue is really good one, so we have very good members for the share check here. You can see many of them. Like if you want to see which one is compression member and which one is tension member working, okay, let's see the compression member. Okay, these are the compression member working on, and this is really bad compression member here. There's some problem here in the compression member over here, so it's because that one is a red one. So if you want to see tension member, you can click on the tension member there, and it will give you the tensile property of each members there. And one very important thing what you can do here is the unity bending check. This unity bending check will give you the result based on the if there is some problem on your member. No calculation is sometimes if the member is very big size, then the needed one generally don't calculate. And blue one is very good because we choose, as I told you, we choose the very big size of the members, so it's giving the blue one, that one, because this is the first trial, so we are choosing the big one. We will get that one to the appropriate one later. So this 0.02 is the your unity bending. That means like the bending when you are applying just the self weight of your structure. Sorry, yeah, self weight of the structure. When you apply, this is the bending you are going to have here. So it should be a little bit more than 0.0, 0.1 or something like that, because these are very big members, but it should not exceed 1. So those are the basic information that I wanted to give you here, and some more are okay. Let's see. One thing I just wanted to tell you here is the when you solve, there is the one result table came here. Let's see the result design results. Click on that one, and it will give you a table here. When you see here, one thing I just want to tell you here is that these members are not appropriate. I already show you that girder, that is the AMFO girder. You can even like see based on that will give you, like if you want to see, you can go on here and material set, No, not this one. I think not here. Yeah, if you go and click on the material set, I'm sorry, I click on it. If you click level, you'll see the which member is. This is the M4, right? This girder is giving uh, slenderness ratio is high here, so we are going to change that one. This gives you all the shapes and the location of share force location and direction and the all the values that we have here, moment, share force, cv value from the s1 s1 equation. And one more thing that you can see is the force on each member from the member force equation. And yeah, these are the all the axial force and the shear force direction, and the moment in g direction you have here for the different members. So this video is already 35 minutes, so I think it will be better to make another video for the getting the appropriate member for this design. Actually, up to here, we what we did is we gave the spreadsheet section set, we drew the all the members, we applied boundary condition on all the members, and the at the ground level we applied the different load, dead load, roof live load, snow load, and the wind load in x direction we applied, and we solved the three load combinations. And we found that for these all just for these three load combinations, some of them are very weak, we can change that one. So here uh, I'm going to make another video over there, and the link for the video will be in the description box, so you can directly follow on that one. So on the next video we will do the select how to select the exact appropriate size of the member for the this load and the this load combination on this structure. So that's going to help you to how to select the appropriate member from the RISA 3D. If you have if you have any questions and any confusion over here up to here, whatever I did for the load combinations and applying the load, solving here, so you can just drop the comment in the comment box below, and I can answer you into the comment whenever I'm available for that one. Thank you for watching this video, and yeah, thank you. We'll see in the next video for the total analysis and total selection of the appropriate members. Thank you.